Hey folks, I got a quick example with using momentum in two directions. So if you want to take one moment to pause the video and copy the diagram down, it's two cars colliding. Don't worry, nobody gets hurt. We all have airbags and seatbelts. But two cars colliding and sticking together. And I want to know what's their final velocity right after the collision, um, before they start sliding to a stop. All right, so the cool thing about momentum is in every interaction, overall momentum of the system is conserved. And it's conserved in any direction you want to look at. So it turns out that the total momentum of this two-car system will be the same before and after in any direction I pick. So I'm going to look at the horizontal or x direction first. So the total momentum in the x direction before they collide is going to be the total momentum in the x direction after they collide. Before they collide, the 2,000 kilogram car has a momentum of mv, which is 2,000 times 20, plus what's the horizontal momentum of the truck, the 8,000 kilogram truck? Well, it's not moving horizontally to begin with, so that's 0. So this is going to be px, the total x momentum of our two-car system, which is 40,000. And it's kilogram meters per second. Okay. We can do the same thing in the y direction. In the y direction, the net momentum in the y direction before is going to equal the total momentum in the y direction after. In the y direction, the 2,000 kilogram car isn't moving in the y direction, so it has no momentum in the y direction before the collision. The truck does, however. It's 8,000 times 15, which will be our total py, which will be 120,000. And same units, kilogram meters per second. What's the total momentum of the two-car system? Well, we have an x and a y, so now we're going to Pythag them. So I draw my right triangle. Px is 40 grand, and Py is 120 grand. If I Pythag those, my calculator gives me 126,500. And I get this angle in an inverse tangent 12 over 4, which is the opposite of adjacent. I get 71.6 degrees. Okay. Now that's my total momentum. Remembering that momentum is mv, v will be momentum over mass, which is 126,500 over the total mass of the two cars. Now they are stuck together, so I have to add their masses together. And 2,000 plus 8,000 is 10,000. And we can do this one without a calculator. You get 12.65 meters per second and it'll be the same angle, 71.6 degrees north of east. Okay, so that's our final velocity of our two-car clump immediately after the collision. Now, other things you might be asked to calculate would be because it's an inelastic collision, they're sticking together, you might be asked to calculate how much energy was lost in the collision. So that would actually be pretty easy. You would find the energy before, which would be the kinetic energy of this guy, which would be 1/2 m times 20 squared, plus the kinetic energy of this guy before, which would be 1/2 times 8,000 times 15 squared. You get a number. That'd be your total kinetic energy before the collision. After the collision, your total energy, kinetic energy, would be 1/2 times 10,000 is your new mass, times your 12.65 squared. And then you would just compare the starting kinetic energy and the final kinetic energy and either subtract them or do a percent or whatever they're asking you to do. So most 2D problems are very similar. You could have elastic or explosion type problems, but they work the same way. The total momentum before is the total momentum after in any direction you choose. I hope that example was helpful, and thank you very much.